This is problem 4 in module 4, and this is our first Monte Carlo simulation in this module. And it's a fairly simple problem. We have a number of ventilated containers that are coming into a port, ventilated because sometimes coffee needs that ventilation. Ships are calling on the port, and we're concerned about the unloading hours that are required as a result of the arrival of the containers on the container ships. We have information regarding the container ships, the ventilated containers on each container ship can be described as having a mean of 10 and a standard deviation of 2.7. The number of ships that arrive at a port with containers on them is uniformly distributed between 0 and 2. So either 0, 1, or 2. And then the unloading hours for each container on a ship is normally distributed with a mean of 12 hours and a standard deviation of 2. So we'd like to create a model that replicates the activity of arrival of ships and the resulting hours required to unload the containers, and then provide some summary statistics, and then ask some probability questions. So if we go to the right, we can see the model that we're going to build, fairly simple. The first thing I do is I generate a brain or create a brain where I place my data, and you can see this is the same information we saw recently in the problem statement. And this is where the calculations are going to take place in this area here. And what I've done here is the first thing that I determine is the arrival of ships. Either 0 ships or 1 ship or 2 ships arrive. And this is a RAND between the numbers that we saw above, 0 and 2. So first we determine the number of ships. Now I'm going to calculate the possibility of the maximum number of ships arriving, which is 2. So I'll calculate what the number of hours required to unload containers. If no ships arrive, of course, that's going to be 0. You can't unload something you don't have. There's no ships. If it's 1 ship, then I have to determine the number of possible containers on that ship. The way I do that is I use this norm inverse function that describes the distribution of containers per ship, and I round that to get an even number of containers. Obviously, it wouldn't do to have a fractional number of containers. So this is the norm inverse function with the RAND as the first argument, then the mean and the standard deviation, and the round and the 0 here say I don't want any fractional values, simply integers. And I do it the same for 2 ships. So I calculate the maximum possible of arrivals. So you could have the first ship and then the second ship. This is the first ship and this is the second ship. But I'm only going to select the value that's associated with the number of ships that actually arrived. In this case, 0. If there is, and this corresponds to this value you see here. If it's 0, then of course the number of hours are going to be 0. Let me hit F9, recalculate this. This time there were 2 ships, so I will include both the first ship and the second ship. This particular function says if this value is 0, then the number of hours is 0. If this value is 1, then I take just this value in this cell. If this value is 2, then I take this cell plus this cell. So that's logically how we get the number of hours required to unload ships. Then I place this in my golden cell. I create a data table, and I generate 1,000 values. You can see some of them are 0, so there are many days where there will be no ships, and some days there'll be a lot. So if we look at this graph, we can see here the distribution of outcomes. There are many days that are going to be about 331 days out of 1,000 that there are going to be no unloading hours. Here is the distribution of the rest of the hours, and we can take summary statistics for that. The summary statistics are here. I grab the data and I take the average of it, the standard deviation. There's a very high standard deviation. Here's the max. Here's the min, of course, no more than 0 hours for the purpose of unloading no containers. And here's the median. Okay, now we create a bins from 0 to our max, which is 380 here. I've allotted up to about 440 to give us plenty of room to capture all the possible arrivals. And I create my bins. I'll show you why I chose 199 rather than 200 here in just a second. Then I create frequency distribution, the cumulative frequency, and then the percent cumulative frequency. And of course, we do this in order to be able to answer those probability questions. So next question is, how many days, or what's the percentage of zero count hours? And we can do that two ways. We can do a count if statement, or which is what I did here, and I got 32.5. So count if you've got 0 and divide it by 1,000. The number of times that 0 occurred divided by 1,000. And that's what's represented here really also. This value will be the same. That bin is 0, that means 0 or less. Now the reason, the next one, question that's asked is what is the probability of 200 or more hours? 200 or more hours will be from this location here. So if I can calculate 199, 0 to 199, or 199 or less, this is going to be about 73.5%. If this had been 200, I would have included 200 in that bracketed value, and I don't. I want to subtract 1 from this value to get the value of 200 or more. After 199, the next value you're going to encounter, obviously, with an integer number of arrivals is going to be 200. So that value from the table is 26.5. It's 1 minus the value here. I could have also counted the number of values. Count if that area has greater than or equal to 200 in it, and divide it by 1,000 to get that percentage. So there you have it. This is our first simulation, quite a simple one, but has all of the elements of what we expect to see in a simulation. That's the end of our problem number 4 in Module 4.